How do you find the surface area of pyramids? We're going to go ahead and discuss how we find the surface area of pyramids throughout this video. This is for section 11-3 out of your textbooks, and this is the first video for the section. Here's a reminder of how your notes should be set up to take notes from this video. Before we have looked at prisms where we had rectangular prisms, and then we looked at ones with, we looked at cones, but what happens if it has one base? Then we have a pyramid, and this is a video for surface area of pyramids. Today you will examine pyramids, and then we'll examine cones in our second video. As you work today, you will discover ways to classify pyramids by their shape and will develop new tools of measurement to find the surface area of these pyramids. Okay, go ahead and copy down the definition of a pyramid, and then when you're ready to follow along with me, go ahead and begin. A pyramid is a solid with a polygonal base formed by connecting each point of the base to a single given point. We call this an apex. That is above or below the flat surface containing the base. Each triangle is a lateral face of a pyramid. So I will discuss and point out some lateral faces for different pyramids. Let's examine the pyramid below. I did not mean to do that. Sorry. If surface area measures the total area of all of the faces, find the surface area of this pyramid. Well, to do that, if you look here, I'm highlighting each different part of face of the pyramid. So there's 1, 2 on the side, 3 in the back, 4 on the other side, and then here you have a bottom face here. So this is a rectangular pyramid. And we can use this given information here to help us find the area, the surface area. And to do that, we just find the area of all surfaces. Okay, so this is not using any given formula except for the one that we've already come into this section knowing, and that's area of a triangle, which is A equals 1/2 base multiplied by height. So remember we saw that there are 4 different triangles. So I will do area equals 1/2 base, which is 8, and height, which is 5. So notice that we can call this this is called a lateral face. And sometimes people refer to this as a slant height because notice it's a slanted line, but it's given the height of that triangle. If you went ahead and took it apart and lifted it up, it would just be a straight triangle up and down, which would also give you the same exact height. So this is 8, and then height is 5. We have 4 of those triangles, so 4 times 20 gave us 80. Now on the left-hand side, 8 times 8 gives us the area of the rectangle, or since it's 8 and 8, it would be a square. So 8 times 8 is 64. 64 plus 80 would give us 124 units squared. And this is just for the surface area of this pyramid. Okay, here's a continuation of that last example. Which number did you not end up using to find the surface area? Why or why not? Notice we never used the internal height. It's not part of the triangles or the rectangles, so we didn't need to use it. But you never know, you might need to use it to find these other measurements that we might need for other problems. For example, let's take a look at this pyramid here. Notice that we are given the internal height, but we're not given the slant height on the side, and that's what we need in order to find the area of this triangle, and then multiply by 4, and then add that to the area of this base of the rectangle. So this time it's missing. Find the height of the triangle, then find the surface area of the pyramid. So the first thing we need is this height. To do that, we can do Pythagorean theorem. Notice we have this right triangle here. So we have 10 squared, which is half of 20, because we're only doing this. Look at how small this is. This is only using half that length. I made sure that it was bold so you can highlight and see that it's only half of that 20. So 10. And then this is, this height here is 24. So by Pythagorean theorem, 10 squared plus 24 squared equals h squared, which is what we're looking for. And then h ends up being 26. So now we have our height that we would need to find the area of the triangles. Once again, we're not using any standard formula except for the area of a triangle. So this triangle right here on the face of it is going to have a base of 20 and a height of 26. So we plug that in here, and that gives us the area of the triangle. And we have 4 of those, so we're going to multiply by 4. The rectangle is 20 by 20. Multiply that, and we add those 2 values, and now we found our surface area. there can be different heights that I've already discussed, but we'll take a look at this picture so you have the information down. A pyramid has two different heights. One is the actual height of the pyramid, which is like the internal height, I like to call it. And the other is the height of the triangles, which is the slant height. This triangle height is called the slant height or the lateral height of the pyramid. So there's two names referred to the slant height. It could also be called lateral height. We use the cursive letter L to represent this length. So when you see a formula used for a pyramid and for also some other similar shapes, if they have L, that could represent the slant height or the lateral height, okay? Not the actual height of the prism or shape. Let's now summarize everything we just discussed about a pyramid. Inside, we have the actual height of the pyramid, which is represented by H. The height of the triangle on the outside of the pyramid is called our lateral height, or we call this the slant height, which is represented by the cursive letter L. The perimeter of this shape is the red outline, the perimeter on the outside. And large letter B, I almost said blue. Large letter B is the blue color, which is the area of this base. We're going to need to know definitely this area of the base and the perimeter to help us with the surface area formula that I'm about to give you. Okay, I was teasing you. What I want to do is take a look at some pictures first, and then we'll look at the formula that we would use for surface area of a pyramid. So here's an example of a pyramid, given your height of the actual pyramid, and then here's the slant height, and this is the 90-degree angle here, because notice it's on the inside. Okay, let's look at some other examples of what if we look at some net figures. Here's a pyramid with a rectangle as its base. And that would be the lateral height, which is right here. So I just took apart a pyramid to show you the different sides. Let's take a look at some other examples. Here's one. This one has a triangle as its base. So you'd have to find the area of this triangle base. And then you would have to find the area of these different three triangles and add that together. Here's another one. This one has a pentagon as its base. And you would do the same thing, find the area of this. Notice you'd have to use A for the area of this base. You'd have to use A equals 1/2 P multiplied by H. And here's one with a hexagon as a base. There's a lateral area. You'd have to use that A equals 1/2 apothem times perimeter again. Let's go and develop a formula now that will give you the surface area of any pyramid. Remember that we would have to find the area of the base, definitely. So there it is there. Find the area of the base. Then we would have to find we could do the perimeter since we can just, since we're going to have to definitely use all of this anyways. And then we could multiply that by the lateral area here. So this is another way to find the surface area of a pyramid by using a basic formula. But if you forgot this formula or don't remember it or can't research it and find it, you can always find the area of all the bases, or excuse me, of the base and of the triangles around it, and then add that together. Here's another way to look at that formula and also a shape. Here is a pyramid that has a 1, 2, 3, 4, 5, 6, 7, 8, an octagon as its base. So you would have to find the area of this base first, which would be the B. You can go ahead and draw arrows to that if you need to. And then you would need to find the height of one of these triangles, which would be L, and multiply that by the perimeter. So that is the perimeter of the bottom part. Okay, it would go 8 around since there's 8 sides. And then you would multiply that by 1/2 and then add that to the base. Area of the base, and you would get the surface area of this pyramid. Let's go ahead and recap surface area for a pyramid and a prism. Remember that for a prism, the surface area was 2 multiplied by the area of the base plus the perimeter multiplied by the height. So this is when two bases and rectangles are for lateral faces. So it could be a triangle could be your base or a rectangle could be your base. And then the surface area for a pyramid is one base and triangles for lateral faces. So this one you have to find the area of the base plus 1/2 the perimeter multiplied by the lateral height. So explain how these two are different. And remember, this is for prisms. And this is for your pyramids. Let's begin to use our surface area formulas for each, define the surface area for each shape. Go ahead and draw the shape, each shape, and give some space, and then the next two slides will display the work for you. I'd like you to practice it on your own though. That would be great to see if you understand what I just discussed. Look at the formula that we just written down in the notes, and then use what is given here to go ahead and plug it in and find the surface area. And then resume the video and follow along with me. This is really great idea for it's a great idea to get some practice in. Okay, so here is our first solution worked out for us. And here's the formula we're using. Remember, this is surface area equals the area of the base plus 1/2 the perimeter and the lateral height. So there's 3 unknowns here. Let's go ahead and figure out each unknown. The area of one of the base is 9 times 9. Well, there's only one base. Remember, that's why it's a pyramid. So 9 times 9 is 81. The perimeter of the base is 9 times 4. There's 4 different sides, so it's 36. And the lateral height is given to us, which is 10. We plug that into our formula and get 261 meters squared. Okay, here's our second example worked out. Notice that they only gave us the inside height, the actual height of the pyramid, and we need this lateral height. So we can use Pythagorean theorem to help us. Remember that this inner triangle that we're drawing here to find this height, this lateral height here, is half of 10, so it's 5. And then we plug in 5 squared plus 15 squared equals L squared. And we get that L equals 5 radical 10. This is also could be a decimal, but we're keeping it as actual value. The area of the base is 10 times 10, which is 100. The perimeter is 10 times 4, which is 40. And the lateral height that we had to use Pythagorean theorem to find is 5 radical 10. Now that we have these 3 known values, we can plug them into our surface area equation formula. And we simplify and we get 81 plus 100 square root of 10 inches squared. Now this is the actual value because we kept our answer in square root. But you can multiply 100 by the square root of 10 and then add that to 81 to get your answer in a decimal form. I would round off to the nearest hundredths for this problem. Okay, we did a lot for this video. We were able to see a lot of pictures of different pyramids and different types of pyramids. And we saw how they can be deconstructed and broken apart and how you can find the surface area of those pyramids. Then we practiced 2 examples. So how do you find the surface area of a pyramid? Look back through your notes and answer this question as your summary. And bring all your questions to class.